Math 128, practice test 2, this is question number 11. And we're given the system with these elements, 0, 2, 4, 6, and the operation is addition modulo 8. So, and the question is it a group? And in order to prove if something's a group or not, we have to run it through those 4 tests. So first off, does it have closure? Is it closed? Is it associative? Does it have an identity? And lastly, is there an inverse? So this is a pretty small group, finite group, so I'm just going to make up a lookup table for it. So 0, 2, 4, 6, 0, 2, 4, 6. And my operation is addition, mod 8. So let's get some cross lines in here, nice and perfectly straight. 0 plus 0 is 0. 0 plus 2 is 2. Actually, 0 plus 2 would be here, is 2. This is 2 plus 0. 4 plus 0 is 4. 6 plus 0 is 6. 2 plus 2 is 4. 4 plus 2 is 6. 6 plus 2 is 8. But remember, we're in mod 8, so it's a 0. 0 plus 4 is 4. 2 plus 4 is 6. 4 plus 4 is 8, but we're mod 8, so it's a 0. 6 plus 4 is 10, but again, it's mod 8, so we're at 2, right? 2 more than 8. 0 plus 6 is 0. 2 plus 6 is 8. Mod 8 is 0. 4 plus 6 is 10. 10 mod 8 is 2. 6 plus 6 is 12. 12 mod 8 is 4. I wrote 0 there, and I meant 6. Okay, so now we'll go through these tests. First off, closure, is it closed? In other words, or do we not generate any new elements when we do all these operations? And having this mod 8 makes it nice, like that 10 goes back to a 2. That 8 goes back to a 0. So notice there's nothing new in here. There's only 2 4s and 6s. So yes, it's closed. No new elements were formed. Next question, associative. So in other words, does the way that we associate the operations matter? So like if I were to take 2, 4, and 6, 2, 4, and 6, and my operation's addition, I could associate them this way, or I could associate them this way. And with associative, the question is, does that always give you back, does the left side always equal the right side? Are these always equal? So let's see, 2 plus 4, it's a 6. 6 plus 6, that's a 4. 4 plus 6, that's a 2. 2 plus 2 is 4. It happened once. We could test a couple more. You know, associative really isn't just does it happen once. Associative is does it always happen. But I know that addition is associative, and this is based on addition. I also know that addition under modulo is associative. So yeah, and here's an example. It's not exactly proof, but it's good enough for us for now. The next question doesn't have an identity. Remember, an identity, is there an element that if you combine it with another element or combine another element with it, you always get that other element back? Well, this is addition. 0 is a pretty good candidate. So notice if I go 0 plus anything, 0 plus anything, I get that anything back. Notice if I go anything plus 0, I get that anything back. So yeah, 0 is the identity. Next question, does every element have an inverse? In other words, can I always combine an element with another element to get the inverse back, to get that 0? So let me look. I get it here, get it here, get it here, get it here. Yeah, absolutely. And not only just that it's in every row and every column, but it's both ways. 2 combined with 6 is 0, and 6 combined with 2 is 0. So yeah, we have inverses, and I'll list them. 0 and 0, 2 and 6, 4 and 4, and 6 and 2. Everything's yes. So is it a group? Yes, it's a group. It passed all these tests.